The natural evolution of human lies, a theory from Mendaciology. The evolution of human language has long been debated with, unfortunately, human language. The natural result is a mess of human lying imagination. The science of lies, Mendaciology, is a computational cognitive neuroscience that can more readily give us insight into the evolution of natural language. The essential points about how human language evolved based on our observations of human lying are these. A brain existed and evolved for a considerable time before human natural language. I hypothesize that nothing we can talk about was not already realized by the pre-lingual brain. Like others such as Chomsky argued, natural language evolved in an evolutionary instant. Human language evolved fully capable of grammatical expression and understanding not by discovering natural language, but by discovering how the brain already computes. That instant was a new inherited memory. We know that primitive brains, let alone advanced brains, have inherited memories. The bug detector in the frog, for example, is an inherited memory that is simply there because you are a frog, not because you learned it by trial and error in trying to eat. There is, of course, also a lot of trial and error by the frog in maximizing his success with this innate knowledge. We know imprinting in birds is an inherited memory, not of who the mother is, but of what a mother is, the need to have one, and how to identify her and what to do with the perceptions of her going forward sick. We, profoundly, know innately what our natural language is, the need to use it, and how to learn it. In all these cases, the innate memory is plainly of a mental recognition and activity concept that is inherited. If we were to look in our DNA for the mutations that mark the beginning of human natural language, we should look for that new inherited memory. It should be for a neocortical field that can recognize, learn, and express natural language, and how that field is wired to the rest of the neural system. In analogy to bird imprinting, it must recognize how memory, perception, action, and thought is organized in the brain, learn how to express and comprehend specific memories, perceptions, actions, and thoughts that are naturally, non-linguistically, brought to attention for expression and communication with another human. The mother must recognize her chicks, and the chicks must recognize their mother, even though neither have ever learned to do so without the help of innate memories. We see this field in the left neocortical regions of the brain, one for recognition or perception, Wernicke, and one for action or expression, Broca. The argument is that the neocortical functions, in detail, are ordinary. But somewhere in the DNA we should find the hereditary memory for language that stimulates the exercise of these fields of neurons expressly for human language. Without that innate desire that understands human natural language and how to bring the communication into being, we would not even try to communicate our cognitive memories, perceptions, actions, and thoughts. That kind of innate memory is not new in most any animal. For example, seeing and acting is such an innate memory field complex. With natural language, such other fields can be spoken about in the way we perceive, act, and think about their perceptions and actions. If we assume that our language field is also just another knowledge field complex, then we can perceive and act on our language field complex too. We can talk about how we talk, and what we said, and why we said it. We can also know if something we heard was, for example, grammatical or not. We might be confused about what was said. Similarly, we might be confused by what we see on occasion, because what we see on those occasions makes no visual sense to us. If this theory is true, then the gene must be for a new specific cognitive self-reference long ago evolved in animals, but never before as an inherited idea of a specific type of communication with specific content among other humans. We can observe these specialized language areas in our neuroscience and do know generally how they compute now, but not in good detail yet. So, did our vocal machinery cause us to learn human language? This theory says no. It was our struggles to speak so others could hear, and to hear so others could speak, that brought about the more sophisticated inherited physical design of human speech and hearing organs. But without the idea, the innate need and inherited memory, we would never even attempt it, and the language-unique sensory and action organs would not have evolved. This gives us a way to guess when human language first emerged as a thing we knew innately. But to progress the other organ evolutions, we had to start with an innate idea of what to do and what others were doing. So I am on the side of those who believe human natural language evolved quickly in a moment of inherited recognition, which over a short time evolved into the supreme capability to deceive each other about the truth, as well as communicate truth with unparalleled precision. If you study Mendaciology, you see this quite readily in the languages that humans learn naturally. Here is the historical background on this subject. Origin of language Wikipedia. The origin of language spoken and signed, as well as language-related technological systems such as writing. It's in.wikipedia.org. Here is one recent paper where the author kind of gets it. But it is not true that human language evolved quickly when we first remembered past events. Dogs remember where they buried their bones. Dogs do not have anything approaching the expressive power of human natural language. They cannot tell other dogs where they buried their bone except to show them. Language evolved for storytelling in a super-fast evolution. The problem of language evolution can be split into two questions. What was language selected for? And what possible? www.academia.edu.here is the study of comparative linguistics, not computational cognitive neuroscience. Although this kind of study is very useful in trying to figure out what that innate idea of human natural language actually is in its detail. For example, what words and word concepts are universal? What syntactic categories are universal? Word orders. How do we fit in the variations in what is spoken, signed, and otherwise visually shown? Evolution of languages. Wikipedia. The evolution of languages or history of language includes the evolution, divergence, and development of languages. n.wikipedia.org. That article, though, fails to mention that any human baby can learn any human natural language. The phrase natural language is actually a technical term. Here is the explanation of what is meant by it. Natural language, Wikipedia. In neuropsychology, linguistics, and the philosophy of language, a natural language or ordinary language is any. een.wikipedia.org. Finally, here is the Mendaciology of human lying. We know a little, but need to know a lot more. Natural language in your brain, it is everything and nothing much. Medium.com. Finally, if you don't think memory about what you can perceive, think about, and do doesn't come in genes. It is refined by birds too. Here is the mating dance of the grebe. By the report, this is the first recording of this age-old dance. Pretty sure that boy and girl didn't explain what a opposite-sex grebe looked like, why to do it, what to do, how to do it, and when to do what, to get hitched, and what would happen next, and how to handle that. Genes provide innate memories for neural network perceiving, thinking, and acting. I can explain how. Can you? Hint, read about natural language in your brain above. This proposed will to talk should have co-evolved in other species as well, and we find that too in fish.